So okay student, so let's see the example number 2. So the question is, we have given a one forest, we have to convert that forest into the binary tree. Okay, so first of all see whether this is a forest or not. See, three components we have here. Okay, three components. Okay, and all these three components are disconnected. Okay, so in the previous lecture guys, we discussed the definition of the forest. So forest is basically what? It's a collection of disconnected components. Okay, and this disconnected components, the each component is basically what? Each component is basically a tree. Okay, now guys, we have to convert this forest into a binary tree. Binary tree means one single tree we have to draw from this forest. Okay, so first of all, see whether this is a binary tree or whatever the trees are given to us is basically a binary tree. So definitely not. In the first component guys, you can see the A root is having three childrens. Okay, and what is the condition of binary tree? Okay, so in the binary tree guys, each node can have at most two childrens. Okay, at most two childrens. Okay, it can have a zero children, one children or two childrens, not more than two childrens. Okay, if it is not containing more than two childrens, that's why it is called as a binary tree. Okay, so definitely this diagram or these trees are not the binary trees. Okay, now let's see guys how we can convert this forest into a binary tree. So first thing that you have to do is you have to connect the siblings. Okay, you have to connect the siblings. To connect the sibling guys, what we have to do? We have to draw some edges. We need to add some edges. Okay, and after that we need to remove some edges that we will see later on. First of all, what I will do, I will add some edges. Okay, so again I am drawing this trees so that you will get an idea how we can solve these questions in the exam. Okay, so again I am quickly drawing this forest once again. Okay, now what I have to do, I have to connect the siblings. I have to connect the siblings. So this is the one sibling, this is siblings, this is siblings, this is siblings, this is siblings. Okay, now here we don't have any siblings, so we are not connecting it. Okay, now if we want to convert this into the binary tree, so binary tree means one tree is having only one root. Okay, so to have the one root, we have to attach the roots of these trees also. Okay, so we are joining these roots with the new edges. Okay, so this is new edge, A to G and G to K. This is new edge. This is the first step. Second step is we have to remove some edges. Now, which edges we have to remove? Okay, see, except the left children edge, we have to remove all the other edges. Okay, except the left children edge, we have to remove all the other edges. Okay, so guys, see here. Now which node I have to, which edge I have to remove here in the A node? This. Okay, because this is a middle children. This, because this is a right children. Now D node is having two children. Okay, so left children is E, right children is F. We have to remove the right children's age. Now comes to G. G is having left children H. We need not to remove this age. G is having middle children I. We have to remove this age. J is the right children. Right children, we have to remove the age. Now K is not having any right children. K is having only left children. So we need not to remove anything. Okay. Let us assume that K is having only right children and not the left children. In that case, we need to keep that age as it is. Okay. But here the K is having left children only. Okay. So now guys, what I am doing, I am drawing this diagram again. I am drawing this tree once again so that you will get the clear idea what we have after this adding and removing step. Okay. So again I am drawing this diagram. So A, B, C, D, E, F, then I have G here, then H, I, J, and now we have K here, L. Okay, so now guys, we have to mark newly added edges. Okay, we have to mark newly added edges. This edge, this edge, this one, this one, this one. Okay, all these tick marks is basically for newly added edges. Why I am doing this? Because I have to tilt these edges by 45 degree. Okay, so that I will get one proper tree. Okay, which looks like a tree. That's why. So what I am doing now, I am drawing this tree once again by rotating or by shifting or by moving this edges 45 degree down. Okay, so now guys, I have so now I have A, then B. So see, A to B, this edge is already there. So I need not to do anything. I need not to shift this. I need not to move this. Okay, then B to C. B to C is newly added edges. That's why I need to tilt this edge little bit, that is 45 degree. Then C to D, again we have to tilt this edge 45 degree. Then D to E. D to E edge is not newly added edge. That's why we have to keep this edge as it is. Then E to F, this is newly added node. That's why newly added edge. That's why we have to tilt this edge by 45 degree. Okay, now guys, comes to G. So A to G, this edge is newly added edge. So we have to shift this edge or we have to move this edge by 45 degree. Okay, so now here we have a G. Then G to H. G to H is already there guys. So we need not to do anything. So we are getting edge as it is. Then H to I, newly added edge. So I will shift that edge 45 degree and I will get I here. Then I to J. I to J is newly added edge. So I will shift that edge by 45 degree and I will get J here. Okay. Now guys, next K comes to K. So G to K, this is newly added edge. Newly added edge, that's why we are shifting that edge. We are moving that edge 45 degree. And now here I will get K. Now K to L. K to L is already there guys. So I will get L here. Okay, now I am not moving this K to L edge because that edge is already there. Okay, so guys, this is my final binary tree. This is my final binary tree. Okay, so I hope you got the idea how we can draw binary tree from the forest. So guys, if you are getting confused with the step number 1 and 2, just again see this video, you will get the idea. Okay, so thank you.